So we'll start taking a look at some of these review problems. So the first one here, this is set up nicely to complete by taking the square root. So if you take the square root of each side, we'd have x plus 2 equals 4, x plus 2 equals negative 4. Subtract 2 from this one, so one answer is x equals 2. Subtract 2. We have x equals negative 6. This next one here, lots of things. We could, this large numbers for the quadratic formula, since it is a no calculator test. So we could try by factoring, or we could do completing the square. So if we factor x squared negative 16x 64, so we multiply these two boxes together. 64x squared, so multiplies to 64x and adds to negative 16. So that's negative 8x and negative 8x. So we have those here. So our outside dimensions, well, this is x and x. X times what gives you negative 8x? Minus 8 and minus 8. So it factors into x minus 8. X minus 8 equals 0. So we have to set the parentheses equal to 0, so this one is just x equals 8. It only hits the x-axis once. So this next one, again, quadratic formula is hard without a calculator here, so let's see. Factor this one, so we have 3x squared, 4x, negative 7. So 3 times negative 7, we have negative 21x squared. So let's see, to add to 7, so that's 4x, 7x and negative 3x. So 7x, negative 3x. Find our outside dimensions here. So we got 3x and x plus 7 minus 1. So it factors into 3x plus 7, x minus 1 equals 0. But we have to set each parenthesis equal to 0, so 3x plus 7 equals 0, minus 7 minus 7, 3x equals negative 7, so x equals negative 7/3. Then we have our other one, x minus 1 equals 0, so x has to equal 1. Next one here, again, this could be a factoring one. So we have x squared, negative 7x, 12. Multiply those boxes together, so we got 12x squared, and adds to negative 7. So we got negative 4x and negative 3x. So negative 4x, negative 3x, x minus 4 minus 3. So if we have x minus 4 and x minus 3 equals 0, our answers would be x equals 4 and x equals 3. This next one, let's remind you guys how to complete the square. So to complete the square, we have to add 12. So we have x squared plus 2x equals 12. And if we draw that picture, we have x squared, split it apart, 1x and 1x. So we have x and x plus 1 equals 12. But to complete it, 1 times 1, we have to add 1 to each side. So this factors into x plus 1 squared equals 13. Take the square root of each side. So we have x plus 1 equals plus or minus the square root of 13. Subtract 1. Plus or minus the square root of 13 minus 1. So that one, I bet we probably couldn't factor it either. So we would have to do the quadratic formula or completing the square. And this last one here, ooh, that looks like a hard one to factor. We could try factoring. Maybe if we did quadratic formula, x equals the opposite of b plus or minus square root b squared minus 4a c all over 2a. So x equals 7 plus or minus the square root. Let's see, what is this? So we got 49 here minus 4 times 3 is 12 times 3 is 36. So is that 13? So the square root of 13 over 6, and we could leave it just like that. Now the next one we're going to take a look at. Let's see. Here's our graph, x squared plus 3x minus 4. Write down the y-intercept. Well, the y-intercept is when you plug in 0 for y. So 0 squared plus 3 times 0 minus 4. So negative 4, or we could say the coordinate 0, negative 4, is our y-intercept. The x-intercepts, so we have to solve it. And I just noticed this one's an easy one to factor. X plus 4 and x minus 1. So x-intercepts, x equals negative 4 and x equals 1. The axis of symmetry, so what goes right through the middle? Well, that's the opposite of b over 2a. So that would be negative 3 over 2 times 1. So negative 3 over 2. So it's x equals negative 3 over 2. And then it says the x-coordinate of the vertex. Well, that's the same thing. So it's negative 3 over 2. This next one here, part of this graph is shown. It passes through negative 5, 0, 1, 0, and 0, 10. Find the values of p and q. Well, those are just our intercepts. So we have negative 5 and 1. Find the value of a. So we know that this is a, x plus 5, x minus 1. From where it crosses, we can use this other coordinate to find a. So 10 equals a, 0 plus 5, 0 minus 1. So let's see, we got 5 and negative 1. So 10 equals negative 5a. So a has to be negative 2. Number 9 here. Write down the coordinates of the vertex. Well, it's in vertex form, so negative 3, negative 6. Find the value of a. F of 1 equals 2. So this is like giving us the coordinate 1, 2. So we can plug in 2 for y. A, 1 plus 3 squared minus 6. So 2 equals, so this is 4 squared, 16a minus 6, plus 6 plus 6. 8 equals 16a, so a would be 1/2. Find the value of f of 3. So our equation is now, we know our a, so 1/2 x plus 3 squared minus 6, and we're plugging in 3. So 1/2 3 plus 3 squared minus 6. So 3 plus 3, 6 squared is 36, so half of that is 18 minus 6. So our answer would be 12. So the next one, we're given an equation. Write the function in vertex form. So we have to find the vertex. Dang, let's see if we can get this back. It's not looking promising. Oh, here it is. So let's see if we can find the vertex here. The opposite of b over 2a. So that's our x-coordinate. So the opposite of b, negative 12 over 2 times 2. So negative 12 over 4 is negative 3. So our y value, 2 times negative 3 squared, 12 times negative 3 plus 5. So negative 3 squared is 9 times 2, so we have 18 minus 36 plus 5. So 18 minus 36, negative 18 plus 5 is 13. And we already know that our A value is right there. So we have the vertex as well. So y, or it's in function notation, so we'll use f of x equals 2x minus 3, so plus 3 squared plus 13. Now this next part here, the graph of g is transformed by 4 units in the positive direction, so that's to the right, and 8 units in the positive y. Find the vertex. Well, our vertex we said was negative 3, 13. So if it moves 4 units in the positive direction, let's see, so that would be 1 and 8 units up, 21. So then we have our vertex there.